Good day to everyone joining us, and welcome to today's X Talks webinar. Today's talk is entitled Healthy Cells, Healthy Results, How to Improve Cell Line Development. My name is Sydney Perlmutter, and I'll be your X Talks host for today. Today's webinar will run for approximately 60 minutes. This presentation includes a Q&A session with our speaker. This webinar is designed to be interactive, and webinars work best when you're involved. So please feel free to submit questions and comments for our speaker throughout the presentation using the questions chat box, and we'll try to attend to your questions during the Q&A session. This chat box is located in the control panel on the right-hand side of your screen. If you require any assistance, please contact me at any time by sending a message using that chat panel. At this point, all participants are in listen-only mode. Please note that this event will be recorded and made available for streaming on xtalks.com. At this point, I'd like to thank Advanced Instruments who developed the content for this presentation. Advanced Instruments is a global company offering novel portfolios of analytical tools across bioprocessing, including Celentum, a portfolio of best-in-class technologies which enable clonal isolation, outgrowth, and characterization in workflows, and assurance of clonality for regulatory bodies. Its Osmotech portfolio includes a robust line of microosmometers designed to support bioprocessing and quality control, and the newest edition, Artel, brings industry-leading solutions to validate, automate, and calibrate liquid handling processes and instrumentation. Now I'd like to introduce our speaker for today's event. Emma Morris has the position of Associate Product Manager at Advanced Instruments based in the UK. Emma has a Bachelor of Science in Biomedical Science from Aston University and has previously worked within the R&D team at AI. Emma has experience cloning and culturing iPSC, CHO, and HEK cell lines, and has also worked as a field application scientist, demonstrating and training customers on Celentum portfolio instrumentation. Emma is now focused on driving the reagent business and supporting AI customers with cell culture supplements. Now, before I pass the presentation over to Emma, we have a poll question for our audience. So you should be seeing that poll on your screen. And that first question is, what percentage clonal outgrowth do you typically see with your CHO cell lines? And please select one of the following: 1 to 10%, 20 to 30%, 30 to 40%, 40 to 50%, or greater than 50%. And that question again, what percentage clonal outgrowth do you typically see with your CHO cell lines? 1 to 10%, 20 to 30%, 30 to 40%, 40 to 50%, or greater than 50%. I'll give our audience another couple of seconds to get in their votes. Thank you very much to our audience for voting. I will close the poll and display those results with you all. So we have 21% for 1 to 10%, another 21% to 20 to 30 for 20 to 30%, 11% for 30 to 40%, 26% for 40 to 50%, and 21% for greater than 50%. Thank you very much to our audience for voting, and we have a second poll question for you, which will be launching on your screen right now. And that question is, how many clones do you typically lose during the clone expansion process? And please select one of the following: less than 10%, 10 to 20%, 20 to 30%, 30 to 40%, or 50 or more percent. And that question again, how many clones do you typically lose during the clone expansion process? I'll give our audience another couple of seconds to get in their votes. Thank you again to our audience for voting. I will close the poll and share those results with you all. So we have 29% for less than 10%, 38% for 10 to 20%, 19% for 20 to 30%, 0% for 30 to 40, and 14% for 50 or more percent. Thank you again so much to our audience for voting in that poll. And now, without further ado, I will pass the presentation over to Emma. And Emma, you may begin when ready.
Thanks for the introduction. Hello, I'm Emma, the Associate Product Manager for Advanced Instruments Reagent Range. Today, we will be discussing the cell culture challenges which exist within the cell line development workflow and how these can be overcome with the use of reagents. Thank you all for joining me today. Let's make a start. In today's talk, I would like to start by giving a quick overview of Advanced Instrument Celentum ecosystem, the INSTI reagent range of products, and how these reagents complement the ecosystem. I will then specifically call out the cell culture challenges which make the cell line development process so inefficient. Specifically, we will focus on poor cell revival, slow transfection and selection recovery, low clonal outgrowth, and loss of clones during the expansion process. Following on from this, I will present a collection of advanced instruments and customer use cases which demonstrate the ability of the reagents to address each of these cell culture challenges. Finally, whilst we also have an INSTI reagent range designed for HEK cell support in the gene therapy workflow, today we will be focusing on the benefits of the INSTI-CHO reagent range for use in the cell line development of monoclonal antibodies and other protein therapies such as bispecifics and fusion antibodies. Let's make a start by introducing the Celentum ecosystem presented by Advanced Instruments. Advanced Instruments have a long history and expertise in the development of osmometers for the biopharmaceutical, food, and clinical spaces. In recent years, Advanced Instruments have built up an instrument, software, consumable, and reagent portfolio via the acquisition of the Celentum and Sal Scientific product ranges. The company have integrated these into a holistic solution for our cell line development customers, which I'm looking forward to sharing with you today. Having worked with customers to understand the key bottlenecks in the cell line development workflow, Advanced Instruments have focused the ecosystem to address these challenges and have further built cell culture expertise to support customer success with the development of stable cell lines for the production of biologics. If you want to know more about the instruments, software, and consumable side of the portfolio, please feel free to visit our website and get in touch for more information. I will now move on and discuss the challenges in cell line development which many of you sat here today will be familiar with, before introducing the INSTI-CHO reagent range. The major challenges which scientists working in cell line development are faced with day to day are summarized step by step on this slide. Right from host cell revival, cells can suffer with poor viability following the harsh conditions which accompany cryopreservation. As a result, scientists often must wait several days or even weeks for the cell's viability and viable cell density to recover before they can proceed with host cell transfection. Right from the start, this can make the process slow to kick off. Once cells have recovered, the next stage in the process is transfection and selection. Depending on the CHO cell line used and the method of transfection, for example electroporation, and subsequent selection recovery, for example the removal of glutamine from the media in the GS-null selection system, this process can be very harsh on the cells. Cells can again struggle with poor viability as they adjust to the expression of the protein of interest. This again may add time to the cell line development workflow. Once transfection recovery and selection are complete, the next hurdle is single-cell isolation to secure a clonal cell line for regulatory approval. This is probably the biggest hurdle our customers tend to face because single cells just do not like to be isolated. As cells are used to living in bulk cultures, cells often struggle to divide and generate colonies following single-cell isolation. This results in poor clonal outgrowth, meaning that scientists often must seed numerous plates to achieve the desired number of clones for screening. Following confirmation of clonality, scientists are required to expand their clones from the cloning plate and adapt them to shaking culture conditions. Shear stress associated with shaking conditions poses yet another challenge to the cell line development process and often results in scientists losing a handful of clones. Finally, when it comes to banking of the top clones, again, the harsh conditions which accompany cryopreservation cause for concern, threatening both viability and viable cell density of the cells. Advanced instruments in situ reagents have been designed and validated to specifically support cell health throughout these stages of the cell line development workflow. When it comes to complete medias, it is often the case that one size does not fit all, and whilst it is easier, simpler, and more efficient to use one media throughout the entire process, the complete medias do not always address the cell's needs at each specific stage, such as freeze thawing, single cell isolation, clone expansion, and changing environments. The INSTI reagents, on the other hand, have specifically been designed and formulated to support cells at these different stages. Let's start by introducing the range. The INSTI-CHO reagents are established cell growth supplements which are animal component free and are all provided with the appropriate certifications. The supplements are fully optimized and ready to use, so there is no requirement for further optimize the concentration for your specific CHO cell type. The reagents can simply be added to the media at the appropriate stage of the workflow. Within the INSTI-CHO range, we have 4 reagents: INSTI-THAW-CHO, INSTI-GROW-CHO and CHO+, and INSTI-SHAKE-CHO. Having discussed the challenges which many of you here today face, I will now go into more detail about each of the reagents in the INSTI-CHO range and explore the benefits each bring to support improvements to the cell line development process. As mentioned, within this range we have INSTI-THAW-CHO, INSTI-GROW-CHO and CHO+, 2 slightly different formulations of the same product which I will explain in more detail later, and INSTI-SHAKE-CHO. Starting with INSTI-THAW-CHO, this reagent was specifically designed to be used in both the cryopreservative mix and in the days following revival to boost cell viability and viable cell density. Cells under freeze-thaw conditions need that extra boost to protect and revive them, and this is exactly what this reagent was designed for. Next is INSTI-GROW-CHO and CHO+. These reagents were specifically designed to support single-cell outgrowth and expansion of clones within static vessels. As mentioned, when cells are isolated, this is not a natural state for them, and so the presence of the supplement protects and supports the cells to divide, increasing clonal outgrowth. INSTI-SHAKE-CHO can be used to enhance transfection and selection recovery where recovery is low. Additionally, INSTI-SHAKE-CHO can be used to support clones as they transition from static to shaking culture. For example, when clones are being transferred from a 96 well under static conditions to a 96 deep well plate under shaking conditions, or even larger vessels such as spin tubes. It is often the transition from static to shaking which causes cell stress, resulting in viability and cell numbers to dramatically reduce. Now that we are all acquainted with the reagents within the range, I will move on and walk through the advanced instruments and customer-generated case studies which illustrate the benefit of these reagents versus negative controls and alternative supplements. I'm going to start with INSTI-THAW-CHO. As mentioned previously, this reagent can be used at both the start and end of the workflow, with both host cell revival and banking and revival of top producers. For this study, we did not use a non-expressing cell line as you would for starting a cell line development campaign, but instead used a CHO-S monoclonal antibody expressing cell line. The reasoning behind this was that cell lines expressing a foreign protein tend to be under a lot more pressure than normal during revival compared to non-expressing host cell lines. However, We do know that some customers still experience challenges recovering their non-expressing host cell lines, so I would again like to highlight that this product can be used for both parental, banking and revival also. We tested several conditions in this study. The first included cells which were banked and thawed with InstaThaw. Our second condition consisted of cells banked under normal conditions and thawed into medium supplemented with InstaThaw. Next, cells were banked with InstaThaw and thawed into medium alone. Finally, cells were banked and revived in the absence of InstaThaw to provide a negative control. For all conditions, cells were banked at 1 × 10⁶ cells per mil. Following revival, the viability and viable cell density of the cells was assessed on day 6 to determine how cells had fared. As you can see, there is a dramatic difference in viable cell density and viability on day 6 post-revival when InstaThaw is used. Cells were happiest and healthiest when cryopreserved and revived in the presence of the InstaThaw reagent. Cells which were either banked or revived in InstaThaw also fared much better than the negative control. Having cells which recover quickly post-revival can really reduce timelines and help customers to get started with their cell line development campaign as soon as possible. Our InstaThaw CHO customer case studies are unfortunately still in progress. However, I am looking forward to sharing the results of these once they are complete. We also have initial data which shows cells can be banked and revived at lower densities in the presence of InstaThaw should cells be difficult to grow in bulk culture. To conclude, we are very excited to see just how much InstaThaw can support the health of our cell banks and ultimately reduce the time spent waiting for cells to recover following revival. The next reagent in the range I will discuss is InstaGrow CHO. In this case study, we showcase clonal outgrowth data between InstaGrow CHO and conditioned medium in 2 repeat experiments. These experiments were conducted under identical conditions but were performed on different days. For those of you who aren't familiar with conditioned medium, this is a technique which involves harvesting medium from a bulk culture of cells and using it to supplement outgrowth media so that cells are tricked into thinking that they aren't in a well on their own. Whilst this technique may improve levels of clonal outgrowth, these improvements are often minimal and are very much dependent on the health of the bulk culture which has been harvested from. In addition, conditioned medium is often considered far from ideal for use, as there is no defined process for harvesting the conditioned medium. Customers are required to define and optimize this process themselves. For example, what day is best to harvest? How long should the conditioned medium be stored for? How much should be added to the wells where the single cell is isolated? And finally, was the medium filtered adequately to eliminate any risk of cell-cell cross-contamination? After all of this, the results can be highly variable due to batch-to-batch variability of the media used and the cells used. In these datasets, we have 2 repeat experiments using a CHO cell line which is expressing a monoclonal antibody. In each run of the experiment, 5 96-well plates were single-cell seeded using the appropriate growth medium supplemented with InstaGrow CHO. In parallel, 5 96-well plates were seeded alongside using the same growth medium supplemented with 48-hour conditioned medium. As you can see, the data nicely demonstrates the ability of InstaGrow to consistently support cells and generate a high population of clonal colonies. By comparison, plates seeded with conditioned medium gave rise to fewer clonal colonies and were outperformed by InstaGrow on both occasions. Before we move on to our first customer use case of the day, I'd like to share this short video of one of our scientists, Chloe, showcasing how to use InstaGrow for single-cell cloning. In this short video, Chloe will compare the clonal outgrowth with medium supplemented with InstaGrow, CHO, versus medium supplemented with conditioned medium. As you'll see, the reagent is really simple to use and partners really nicely with the VIPS Pro single-cell seeder.
Hi, I'm Chloe, a diamond scientist at Advanced Instruments. Today I'm going to show you how we use InstaGrow to enhance clonal outgrowth during our single-cell seeding experiments.
InstaGrow is an animal component-free cell culture supplement designed to enhance growth and improve cloning efficiency of CHO and HEX cell lines in liquid or semi-solid media. The reagent is really easy to use and comes as a 20 times concentrated solution, which should be diluted to a final concentration of 1 times in your outgrowth medium for single-cell seeding.
The project I'm working on at the moment involves a CHO cell line which is expressing a monoclonal antibody. I'm therefore going to be using our InstaGrow CHO reagent.
To ensure that the cells are in their log phase of growth, I passaged the cells 48 hours ago. I also primed my cells for single-cell seeding by adding InstaGrow CHO to my culture flask yesterday. The cells have now been cultured with a 1 times concentration of InstaGrow CHO for 24 hours and are therefore ready to be single-cell seeded. I'm going to start by preparing my outgrowth medium. This particular cell line is cultured in 40 CHO medium. I'm going to add InstaGrow CHO to a final concentration of 1 times to my 40 CHO medium, in addition to the selective reagents and supplements which I use in general cell culture. Next, I'm going to count my cells and check that they are greater than 95% viable. As I'm going to be using the VIPS Pro today to seed my cells, I need to dilute my stock of cells to 9,500 cells per ml. Once my InstaGrow primed cells have been loaded into the VIPS Pro cell reservoir and the medium fill line has been primed with InstaGrow supplemented outgrowth medium, it's time to let VIPS Pro do the work. Once VIPS Pro seeding is complete, I simply fit the lid onto the plate and pop the plate into the incubator. As you can see, we have some really nice outgrowth which we have been able to verify as clonal thanks to VIPS Pro's whole well imaging capabilities. So that you can appreciate the benefit of using the InstaGrow CHO reagent, here are some clonal outgrowth results where conditioned medium was used. As you can see from the results, InstaGrow CHO significantly outperforms the use of conditioned media, which is in line with what we typically see in-house and amongst our customers.
Thank you for watching.
Thanks for that, Chloe. We'll now move on to our first customer use case of today. Here we have a direct comparison of clonal outgrowth between InstaGrow CHO, InstaGrow CHO Plus, and the customer's standard outgrowth medium. You will notice that both InstaGrow CHO and CHO Plus have been included in this study, so I would like to further explain the differences between these two before we move any further. Both reagents are designed to enhance single-cell outgrowth. However, the formulation of InstaGrow CHO Plus is slightly different to cater for the different CHO cell lines and outgrowth medias used by customers. The name CHO Plus can often give the impression that it is superior in performance to InstaGrow CHO. However, it is highly dependent upon the cell line, medium used, and often the protein being expressed. If customers are trying the reagent in their workflow for the first time, we recommend that both reagents are tested to see which offers the greatest improvement to clonal outgrowth. Focusing back on the customer case study, 7 different monoclonal antibody expressing CHO cell lines were single-cell seeded into 384 well plates via limiting dilution. On this occasion, the customer's cell line preferred InstaGrow CHO Plus. However, remember that this is not always the case, as the preferred formulation of InstaGrow is very much dependent on the CHO line, medium used, and protein being expressed. This customer was very pleased with the outcome of this evaluation, having struggled for months with little to no clonal outgrowth. InstaGrow customer case study shows a comparison between InstaGrow CHO Plus and the customer's own proprietary cell culture supplement, which they defined and developed themselves over several months. As with the previous dataset, the percentage clonal outgrowth achieved in the presence of the Instagrow CHO Plus was much higher. In addition, the customer also evaluated the number of weeks following single-cell seeding for 70% of the clones to reach 50% confluence in the cloning plate. As you can see, the clones grew much more quickly in the presence of Instagrow CHO Plus, enabling the customer to shorten their workflow by 1 whole week. To quickly summarize this case study, the customer was able to gain back precious time in their workflow, in addition to being able to seed fewer plates thanks to the improvements to percentage clonal outgrowth. We will now move on to our final Instagrow dataset for today. I'd like to start with a bit of background on this customer. This group had been using a commercially available competitor for Instagrow and were very happy in terms of the levels of clonal outgrowth which they were achieving. However, unfortunately, they were also experiencing a lot of debris in the medium when they used this product, which, as we all know, does not fit well when you are trying to prove clonality to the regulator. This customer therefore approached us early last year and asked whether they could evaluate the performance with a few of their pools. 4 different pools were assessed, 2 with Instagrow CHO and the other 2 with Instagrow CHO Plus. In both cases, cloning medium 1, which was Instagrow's commercially available competitor, and cloning medium 2 were run alongside. As you can see, in 3 out of the 4 cases, Instagrow CHO or Instagrow CHO Plus outperformed the cloning medium 1. Only pool 3 performed better with cloning medium 1. However, this difference is very marginal, and remember there would have been a lot of debris in the media which the group would have had to justify to the regulator. To summarize the data presented in the last few slides, the challenges associated with single-cell isolation are a massive hurdle for our customers to overcome. Whilst there are automated single-cell seeders on the market to increase the number of wells in a plate which contain single cells, if cells die following seeding because their environment is not favourable, then this is a no-win situation. Scientists will still be faced with having to seed a high number of plates to achieve the required number of clones needed for screening. This increases the time spent on the process, the consumables, and increases the amount of labour required for processing more plates. In addition to this, today we have also considered condition medium. Whilst this is a very low-cost solution to improving clonal outgrowth, it is often subject to batch-to-batch variability, meaning that performance improvement is not guaranteed. The data presented today demonstrates that Instagrow consistently outperforms condition medium, and even customers' own developed proprietary supplements, enabling scientists to cut down the number of plates, consumables, and labour required to achieve the starting number of candidate clones for the cell line development workflow. We will now move on to explaining the uses and benefits of InstaShake CHO for adapting clones to shaking culture. Following single-cell isolation and outgrowth, clones are expanded and adapted to shaking culture so that they can be grown at higher densities. This not only enables clones to be banked for future research and master cell banks, but also enables protein expression stability studies to be conducted. Furthermore, once clones are in shaking culture, fed batch studies can be conducted to screen for clones which are best suited for the conditions which accompany bioreactor production. In essence, scientists need to know which clones can be grown at higher densities and produce sufficient quantities of the protein of interest. Whilst some clones make this transition from static to shaking culture seamlessly, other clones suffer with low viability due to the shear stress which accompany shaking conditions. In our first customer case study, 24 clones were transitioned from 24-well static culture to 50 ml mini bioreactors with InstaShake CHO. A a second panel of 24 clones were transitioned side by side without the presence of InstaShape Cho for reference. As you can see, the customer's clones really benefited from the support of InstaShape Cho reagent. 20 out of the 24 clones transitioned successfully to shaking culture in the presence of InstaShake, compared to only 2 from the control group. Furthermore, the number of days taken for the clones to reach 3 times 10 to the 6 cells per mil and viability greater than 85% was reduced from 17 to 10 days. The time, labour and consumables saved by firstly not losing clones in the expansion process, and secondly reducing the recovery by 7 days was a huge milestone for this customer in terms of improving their workflow efficiencies. In our final use case presented here today, the customer's workflow again benefited from the use of InstaShake to support adaptation to shaking culture. In this evaluation, the customer expanded 37 clones from 50 ml spin tubes to shake flasks with and without InstaShake before undergoing a fed batch study. 19 clones were expanded in the presence of InstaShake Cho, while a further 18 clones were expanded without to provide a negative control. Data presented on the left-hand side shows details of the expansion process and how clones from each of the groups fared. While 12 clones were successfully expanded to shaking conditions in the presence of InstaShake, with viable cell density greater than 0.7 times 10 to the 6 cells per mil, only 6 clones from the negative control group made it. This was an immediate 50% increase in the number of clones available for the customer to begin screening. As expected, fewer clones were completely lost in the presence of InstaShake. Only 2 clones from the InstaShake clones were lost compared to 3 from the negative control group. The final category which the customer noted was the number of clones which had low viability following expansion but were recoverable. This was halved in the presence of InstaShake, meaning that the customer had far more healthy clones in shaking conditions ready to take forward to fed batch. The final point from this case study is the clone's performance once fed batch commenced. On the right hand side you can see that both viability and viable cell density was enhanced in the presence of InstaShake, leaving this customer very happy. To recap the final data sets presented today, whilst some clones adapt seamlessly to shaking conditions, others struggle with low viability and poor viable cell density, which ultimately leads to cell death. The data clearly shows that InstaShake supports cells adapt to shaking conditions, saving scientists time, labour and consumable costs during the clone expansion process. I would also like to add, whilst we do not have the data here today, we have preliminary customer results which show InstaShake may also provide benefits during the transfection and selection recovery process. Our initial data indicates that cell recovery during the selection period is faster with higher cell viability in the presence of the reagent. This in turn will save additional time and ensure cells have high viability so that single cell seeding can start sooner.
With the final summary of our last reagent in the INSTI range from Emma, I, Andrea Goff, the Associate Director of the Biopharm Reagents and Application Sciences, wanted to take this time to go back to the CLD workflow and provide more information on our other solutions for those of you who are not familiar with them. As mentioned during the introduction, if you would like more detailed information on any of our products, please do visit our website, or better yet, get in direct contact with us and we'll be happy to tell you more. As well as reagents, the ecosystem offers instrumentation, consumables and software for increasing efficiencies across the workflow. I will now walk you through each of the Celentim instruments displayed on screen and tell you more about each. I wanted to start with VIPS Pro. This is our gentle single-cell cloning platform for high seeding efficiency, which, when combined with InstaGrow growth supplements, provides high cloning efficiency, as we've shown on numerous slides before. It is our industry-leading imaging system with AI-driven cell detection that provides reliable identification, confirmation, and documentation of a single cell for what we call the double lock of assurance of clonality. The clonality report that is automatically generated by this instrument is easy to use in IND submissions, and the instrument has fully integrated Studious software for data management and automated decision making, and it has 21 CFR Part 11 compliant features. Finally, the system comes with single-use consumables for simplicity. The next instrument in the range is the Cellmetric X. This is our automated benchtop high-resolution, high-contrast imaging system developed specifically for visual assessment of a single cell growing into a colony. Artificial intelligence-based automated evidence of clonality feature saves time and reduces project length by identifying cells automatically at day 0. Integration into Studious data management and analysis platform tracks a single cell's journey through seeding, outgrowth to clonally derived colonies, and productivity assessments with automated clonality report. We also have 2 versions of this system, the Cellmetric XHT and robotic integration, that enable walkaway operation for hundreds of plates if that's what the workflow demands. The final instrument in the range is the ICON. This instrument is for clone selection and characterization based on critical quality attributes. The system combines clone titer, cell counting, and viability measurements all in one instrument. The system is designed for clone expansion and fed batch CLD process, and the low sample volume assays allow peak VCD and titer measurements from 96, 48, or 24 well plates. This and all enables the user to select clones earlier, and there's only need for 1 titer assay standard curve per project, saving the user time. The plate-based titer assay only requires 60 microliters of sample, and a 96 well plate can be processed in 6 minutes. And the cell counting and viability assay only requires 20 microliters of sample, and again 24 samples are processed in 4 minutes, all of which saving the user vital time. Finally, and probably the most important feature of the Celentum ecosystem, is the Studious data management platform. Previously, users tracking clones through the CLD process would do so with numerous spreadsheets, which can be cumbersome and prone to error. Studious eliminates that challenge by managing data in a single secure database from all the instruments in the ecosystem. Studious combines seeding data from the VIPS Pro, clone monitoring data from the Cellmetric X, critical quality attribute data from the ICON, enables data analysis and clone triaging, and finally provides the history tree for tracking the life of the clone. This provides the secure clone tracking and removes the need for the spreadsheet, making data analysis achievable in minutes, not days, giving the user better, faster, and more confident decisions. Now I will hand back to Emma to conclude today's talk on the benefits of the reagents to improve cell line development.
Before I conclude today and open up for questions, I would like to quickly walk through some frequently asked questions from our customers. Our first frequently asked question is, what is the shelf life for InstaGrow Cho, InstaShake Cho, and InstaThaw Cho? All of our reagents have a shelf life of 18 months. Once opened, there is no set time frame in which the reagents need to be used. Simply use the reagent within the 18 months as described on the certificate of analysis. Our second commonly asked question is, where are the Insta reagents manufactured? All of Advanced Instruments Insta products are manufactured at our UK site in the southwest of England. Each batch of reagent is subject to both functional and sterility testing, which take a total of 2 weeks to complete. Next, We are frequently asked whether our Insta reagents can be used for both adherent and suspension CHO cell lines. In answer to this, whilst the reagent was originally formulated and validated for suspension CHO cell lines, we have had great success with adherent CHO cell lines, both internally and amongst our customer basis. Next, are the Insta reagents validated for use with cell lines other than CHO? Yes, we actually have a second series of Insta products which cater for HEC cell lines. Like our CHO range, we have an InstaGrow HEC, InstaShake HEC, and InstaThaw HEC, which are all commercially available. Another frequently asked question is, do the reagents need to be used in combination with a specific medium or supplement? The answer to this is no. Simply add your InstaGrow, Shake, or Thaw to your standard medium, including any other additives or selective reagents which you usually use. Specifically for InstaThaw, many of our customers like to clarify that InstaThaw is not a replacement for DMSO. The answer to this is no. InstaThaw should be considered as an additional supplement to your chiroprotective solution. Our final frequently asked question for today is, do we offer different size quantities of the Insta reagents? In answer to this, we offer both 5 ml and 25 ml quantities of the InstaGrow CHO and InstaGrow CHO Plus reagents. InstaShake CHO is only available in 25 ml quantities, while InstaThaw CHO is only available in 5 ml quantities. To recap today's talk, the cell line development workflow is thought with bottlenecks such as poor recovery following revival and low viability following transfection. Scientists are also faced with low to little clonal outgrowth and loss of clones following transition to shaking culture. These together make the workflow extremely long and costly, leaving many of us looking for solutions. Together, InstaGrow, InstaShake, and InstaThaw CHO reagents help support cells overcome these challenges and make workflows more efficient. Thank you for listening. I will now answer any questions from the audience.
All right, well, thank you very much for that insightful presentation. Before we get to the Q&A, we have a couple more poll questions for our audience. So I will start with the first poll question, and that is, which would you consider your greatest pain point in the CLD process? Please select one of the following: low clonal outgrowth following single cell seeding, slow recovery following transfection or selection, loss of clones during static to shaking expansion, or low viability and viable cell density following revival. And that question again, which would you consider your greatest pain point in the CLD process? And please select, any of the following: low clonal outgrowth following single cell seeding, slow recovery following transfection or selection, loss of clones during static to shaking expansion, or low viability and viable cell density following revival. And I'll give our audience another couple of seconds to get in their votes. Thank you for voting. I will close the poll and share those results. So we have 40% for low clonal outgrowth following cell seeding, 27% for slow recovery following transfection or selection, another 27% for loss of clones during static to shaking expansion, and 20% for low viability and viable density following revival. And we have one final poll question for our audience, which I'm launching on your screens right now. And that question is, for single cell outgrowth support of CHO cells, what options have you tried so far? And please select any of the following: conditioned media, own selection of supplements, alternative commercially available supplements, InstaGrow CHO or CHO Plus, or none of the above. And that question again, for single cell outgrowth of CHO cells, what options have you tried so far? And you can select any of the following: conditioned media, own selection of supplements, alternative commercially available supplements, InstaCho, Instagrow Cho or Cho Plus, or none of the above. And again, I'll give our audience another couple of seconds to get in their votes. Thank you again to our audience for participating in these poll questions. I will close the poll and share the final results. So we have 62% for conditioned media, 15% for own selection of supplements, 31% for alternative commercially available supplements, 38% for Instagrow Cho or Cho Plus, and 15% for none of the above. All right. With that, now we can get into our Q&A session. So Emma, we've already received some audience questions, so I will start with those. So our first question is the InstaThaw reagent data also using DMSO, or is the reagent not compatible with other cryoprotectants?
Thanks. So all of the banking data presented today, DMSO was present for. So InstaThaw isn't considered a chiroprotectant itself. It's an additional supplement which you use with your chiroprotectant of choice. So most commonly DMSO.
Thank you very much for that answer. Our second question, can you supplement a post-selection culture with both InstaCho and InstaShake prior to single cell cloning?
I wouldn't supplement with both InstaGrow and InstaShake Cho at the same time. If you're, I assume you're talking post-transfection and selection, so I'm assuming that the cells will be in bulk cell culture, so I would recommend the use of InstaShake Cho to support the cells during that period.
Thank you very much. Our next question is, I have a CHO cell line which struggles in shaking culture conditions. Do you have any suggestions for how I can support it?
Again, I would recommend trying InstaShake Cho. So this reagent is specifically designed to support the viability and viable cell density of cells when they're in shaking culture conditions.
Thank you very much. Our next question, can the InstaCho reagents be used to support adherent CHO cell lines?
So the InstaGrow Cho and Cho Plus were originally designed and formulated to support suspension Cho cell lines, as this is typically what's used in cell line development. However, saying that, we've had a lot of success both in-house and amongst our academic customer basis, and they've again had great success with adherent Cho cell lines and Instagrow Cho and Cho Plus.
Another audience member would like to know, I've been using Instagrow Cho to improve clonal outgrowth. What is the process for switching to using InstaShake for clone expansion?
So Instagrow is used during the seeding process. It can then also be used as you expand the clones from the cloning plate into other static vessels. But then once you're ready to move those clones into shaking cultures, that is when you would switch from using the Instagrow reagent to the InstaShake reagent.
Thank you very much. Our next question, can you supplement a post-selection culture with both InstaCho and InstaShake prior to, oh, sorry, did I ask this question already?
I think so, yeah.
I believe, sorry, my
That's okay.
apologies. Another question, do these Insta reagents work on hybridoma cells?
So we have two ranges of the Insta products, so InstaCho products and InstaHec products, and they've both been designed specifically for that cell type. Hybridomas will likely have their own requirements and supplements that they need to grow. So I think it's best if you get in contact and we can discuss the needs of your cell line further.
All right, another audience member would like to know, are you planning to have spec media for human iPSCs?
So we don't have a growth medium for stem cells, but we do have a matrix which is called matriclone. So this can be used to pre-coat and also be used in solution if you want to remove the pre-coating step from your workflow. And it's helped support stem cells in both passaging and single cell seeding, and helps them maintain their pluripotency.
All right, well, thank you very much for those answers. So we've reached the end of the question and answer portion of this webinar. And if we couldn't attend to your questions, the team at Advanced Instruments may follow up with you, or if you have further questions, you can direct them to the email address on your screen. Thank you everyone for participating in today's webinar. You'll be receiving a follow-up email from X-Talks with access to the recorded archive for this event. And a survey window will be popping up on your screen, and your participation is appreciated as it will help us to improve our webinars. Now I'm about to send a link in your chat box, and you'll be able to view this webinar, and you can share this link with your colleagues as well. So I encourage you to do that. Now, please join us in thanking our speaker, Emma Morris. We hope you found this webinar informative. Have a great day, everyone.